first I need you to be familiar with a couple of terms that we're going to be using, and I'm going to be using these all the way through this lecture, so make sure you understand them now. If you need to pause it, if you need to remember them, make sure you do. So, fraction, we have an example here. We've got 3 out of 4. Just here. This is an example of a fraction. It has 2 parts, a number at the top and a number at the bottom usually, although there are other kinds of fractions which we'll go through later. But generally, it will have a numerator, which is the number at the top, and a denominator, which is the number at the bottom. Make sure you're familiar with those terms. So, for example, in our fraction, in our 3 over 4, or 3 quarters, or 3 out of 4, we have 3 is the numerator, and 4 is the denominator. Now this is, interestingly, it's also the same as saying 3 divided by 4. So obviously we can calculate this out. And if we actually do that calculation, then we change the terms. The terms would be the dividend, in this case 3 would be the dividend, and 4 would be the divisor. The result of that calculation would be this, 0.75, and that's what we call the quotient. The result of the calculation from a fraction is the quotient. So there are different kinds of fractions. The fraction that you'll most often have seen probably before this is called a proper fraction. A proper fraction is where the numerator, here, number 5 in this case, the numerator is less than the denominator, or the 6. So where the numerator is smaller than the denominator, that's what we call a proper fraction. An improper fraction is where the numerator is bigger or greater than the denominator, such as this one, 6 over 5. 6, the numerator much bigger, well, not much bigger, a bit bigger than the denominator, and that makes this an improper fraction. Now, we can turn an improper fraction into a mixed fraction, and I've got an example here. So here I have 6 over 5, or 6 fifths, and I know that 6 fifths is the same as saying 5 fifths plus 1 fifth. The same as saying 5 out of 5 plus 1 out of 5. And that can be turned into 1 and 1 fifth, because of course 5 divided by 5 is 1. Now, quite often in science and engineering, we need to be able to add or subtract fractions. In order to be able to do that, we have to get the denominator the same. So you can't add 1 over 2 to 3 over 5 just by some quick method. We have to get the denominator the same. Now, just to remind you that different fractions can be expressed in many different ways. So, for example, here we have 1 over 2, or 1/2, and that is actually the same as 2 over 4, which is the same as 3 over 6. You put those things into your calculator, you're going to get the same result. The quotient will be the same. But when we want to add or subtract different fractions, we need to make sure that the denominator is the same, and that's what we call a common denominator. Now, to give you a little bit of insight based on what we did a couple of weeks ago, the lowest common denominator is the lowest common multiple of the denominators of all the fractions. So, if you need to remind yourself of what that is, if you need to remind yourself what the lowest common multiple is, you should go back and have a look at week 1. Now, there are a few different ways of looking at this. If you just want to add up a simple fraction to another simple fraction, there's a really simple way that we can do this to find the common denominator. For example, here I have 1 over 4 plus 2 over 3. I need to find a common denominator, and the simplest way to do that is to multiply 4 by 3 to get 12. The reason that works is because I know I can turn the fraction into a different fraction but with the same information, and I'll explain what I mean by that. We can change the denominator, but if we do that, we have to keep the fraction the same. It needs to have the same information in it, and that means that when you put it into a calculator, you need to get the same quotient out. So what we do is we multiply both top and bottom by the same number. So first we were dealing with 1 over 4, a quarter, here. In this case, I want to multiply 4 by 3 so that I have a common denominator, 12. But to keep that fraction the same, I have to multiply the top by the same number. So I've got 1 times 3 divided by 4 times 3. Then I'm going to do the same for 2/3 here. But this time I'm going to multiply both top and bottom by 4, the denominator of the other fraction. That means I end up with 2 new fractions, but they do, believe me, have the same information in them. 3 over 12 plus 8 over 12. Now, we can add those up really easily by just adding the numerators together. 3 plus 8 is 11, so 3 over 12, or 3/12, plus 8/12 equals 11/12. But what about if we have lots of fractions that we have to add or subtract together? Well, in this case, we can use what we learned about the lowest common multiple. Again, if you can't remember what that is, please go back to week 1 and have a look at it. In this case, we have a sum, which is 1 over 2 plus 2 over 5 minus 3 over 8. Well, how do we even start to approach this? We could do it the way I've just shown you. We could just deal with the first 2 fractions, change to the same denominator, in that case would be 10 using that method. And then once we had a new fraction for those first 2, then we could do it for the second fraction. But there is a quicker way, and that is to use the lowest common multiple. Just to remind you, to get the lowest common multiple, we have to get down to the factors of those individual numbers and then multiply them together to find our lowest common multiple. Now in this case, if we factorise 2, it's just 2, it's a prime number. And the same for 5. 8 is actually the only one we can prime factorise. And if we do that, we actually discover that we can divide it by 2, which would be 2 times 4, which of course is 2 times 2. So, factorised, apologies for that, it's difficult to write on this, is 2 times 2 times 2. So our lowest common multiple is going to involve the factors 2 and 5. And if you calculate that out, it's going to be 2 times 2 times 2 times 5, which is 40. So I've determined that the lowest common multiple of these 3 denominators is 40. Well, now I have to convert those fractions. So how do I do that? Well, I do exactly the same thing. I have to look at how I keep that fraction the same. So if I'm converting 2 at the bottom here as the denominator of 1/2 to 40, how do I do that? Well, I've multiplied 2 by 20 times. So I have to do the same to the top of the fraction here. So 1 over 2 becomes 20 over 40. 5, the denominator of the second fraction, goes into 40 8 times. So I have to multiply the top of that fraction by 8 as well. And that gives us 16 over 40. For the third fraction, again, 8 goes into 40 5 times. So I have to multiply both top and bottom by 5, giving 15 over 40. Now you can see here that I can write it in this fraction either with separate fractions over the same denominator but separated out, or then on the next line I can actually combine these and have 20 plus 16 minus 15 all over 40. Again, if you want to check that with your calculator, you can, but that means the same thing. And again, it's reducing the amount of information we have to do. And if we want to calculate it out, it's reducing the amount of processes we have to follow. So if I do 20 plus 16 minus 15, that's 20 plus 1, and that gives an answer of 21 over 40. Thankfully, multiplication of fractions is a lot easier. I do admit that adding and subtracting fractions together is a bit clunky. You need to practice that. Multiplication is actually a much simpler process. All we do to multiply fractions together is we multiply all of the numerators together up here, and we multiply all of the denominators together down here. So in this case, we have 1/2 multiplied by 2/5 multiplied by 3/8. At the top, we have 1, 2, and 3. We multiply all of those together, 1 times 2 times 3, which gives us 6. Then we do the same for the denominators to give us our new denominator. 2 times 5 times 8 at the bottom here, which gives us 80. That gives us a fraction 6 over 80. Now, you may well have noticed that that fraction can be what we call simplified. Simplifying means removing as much information as possible without changing the meaning. It means making things simpler. So here we want to reduce the numbers to the lowest possible value we can. It's a little bit like when we looked at factorising, but here, as long as we divide both top and bottom of the fraction by the numerator, both the top and the bottom of the fraction, the numerator and the denominator by the same thing, we can forget the information because the result or the quotient of that would still be the same. So here you can see we have 6 over 80, which has been simplified by dividing both top and bottom by 2 to 3 over 40. It's good practice to always take a fraction down to the lowest numbers we can. So if you can factorise those numbers and reduce it down, you should. And just to show you why that works, we can actually write 3 as a fraction. We could call it 3 divided by 1. And if we do that, then we have 1 times 3 at the top and 4 times 1 at the bottom. So it does still follow our multiplication rule, if you know that 3 is the same as 3 over 1. But don't get too mixed up on it. Just try and remember that if it's a whole number, you can just multiply the top number, the numerator, by that number. Okay, division. Actually, this is also pretty simple, but there's a trick to it. You have to know that dividing by a fraction is the same as multiplying by the flipped or inverted fraction. Again, you'll have to try this on your calculator if you want to understand it or see it, but I can give you an example here. For example, I have a sum 2 over 5 divided by 3 over 8. Now, in order to calculate that or to simplify it, I'm going to flip the 3 over 8 to 8 over 3 and change the sign from a divide to a multiply. So my new calculation is 2 over 5 multiplied by 8 over 3. That's a top-heavy or improper fraction. Now we just follow the same rule we followed for the other multiplication sums. So we multiply the numerators together, so we get 2 times 8 at the top. We multiply the denominators together, we get 5 times 3 at the bottom, which is 15. So we end up with 16 over 15. Now again, that's an improper fraction, so ideally what we want to do in this case is we can take it to be a mixed fraction of 1 and 1/15. Now this will be coming up again in a few weeks, but I thought we'd take a look at it now very quickly. We can actually apply powers to fractions in the same way we did to whole numbers last week. If you see a power applied to a fraction outside of some brackets like this, then it's really easy to get rid of that, to actually be able to calculate that out. All we do is it's actually the same as saying that we apply the same power to both the numerator and the denominator. Now, you might have to get a bit used to us using letters in place of numbers. In this situation, A represents a number, B represents another number, X represents a third number. Try not to get too confused by that. I'll give you some number examples now. There's another example below. Have a look at that if you like by pausing the video and seeing if you can check it with your calculator.